Welcome to the 18th episode of the Building Interactive website series, where we'll go over conditional statements in JavaScript. So the reason why we need conditional statements in our code is because they allow us to run different code depending on whether a specific condition is true or false. If we didn't use these types of statements, then we need to use weird, janky loopholes or tricks to recreate the same effects, which is much more difficult and less easy to maintain. The first way of conditionally running code is through if statements, which take in a condition, which is basically a yes or no question that resolves to a Boolean value. You can either pass a Boolean value directly inside, or you can use a comparison operator to compare two values together. We can test if statements by first typing in if and then selecting if block, which is the first option here. And now you can see it creates a structure with if and then a pair of parentheses and then a pair of curly braces, which contains the code that will be executed if the condition in the parentheses is true. So we can test this by setting the condition to always be true by typing in true. And then we can log a message to the console saying this executed. And now if we run the code and go to the browser console, you can see this is printed out. However, if we were to type false, then you can see it doesn't run anymore because false is not equal to true, meaning this code is never reached. However, putting true or false as the condition here really isn't that useful, except for when you want to create a block of code that you can manually disable and enable by changing the text inside these parentheses. So in order to make this condition more dependent on the circumstances of the situation, we can take a look at conditional operators which compare two values together. So here we can create a number variable that we can use to show off numerical comparison of values. So for example, we can call this test num because this is the number that we'll be testing in this condition. So we can set it equal to 5 as an example. And so now we can say if test num and then an angled bracket pointing to the right, which signifies greater than, and then we can say 4, for example. Then if we go to the console, you can see this code executes because 5 is greater than 4. However, if we were to change the number to 3, you can see it no longer executes because 3 is no longer greater than 4. We can also check if 3 is less than 4, and as you can see, it is, as shown by this executed appearing in the console. However, if we change it back to 5, you can see it doesn't show up anymore because 5 is not less than 4. We can also do less than or equal to, which checks if the value is less than or equal to another value. So you can see with 3, this prints out again. However, if we try 4, this executed still shows up because testNum is less than or equal to 4 because it's equal to 4. And it's a similar story for greater than or equal to 4 with the angle bracket facing the opposite direction. You can see it still prints this message out to the console. Note that these numerical comparison operators also work when the operands are strings. So if we were to run the code, you can see 4 is still greater than or equal to the string 4 here, and we can even test it with different numbers. So you can see 4 with the quotes works exactly the same way as 4 without the quotes, meaning it's not too strict of a comparison. These equal to and not equal to operators also work with number values and Boolean values. However, if you try to use them with arrays, so I can say 1, 2, 3 in this case, and if I were to ask is it equal to seemingly the same array, you can see the code does not execute. And the reason why is because unlike strings, numbers, and booleans, these are not primitive values. A primitive means that the value itself is compared when using these comparison operators. However, arrays are considered objects. This means that instead of the value being compared, the addresses in memory will be compared. And since these two arrays are located in different areas of the computer's memory, this means this code will not execute. And if we were to do not equal to, you can see it produces the opposite result. In fact, we can actually call this test array to be more correct here. However, if we were to define another array called test array 2 and then set it equal to test array and then check if they're equal to each other, you can see they are equal to each other. And this is because when test array 2 is assigned test array, it's not just assigned the value of test array, it actually points to the exact same memory address. This means that changes in one array will actually affect the other array and vice versa. And this also means these two arrays are exactly the same. Same values, same memory address. Meaning, if you check them using the equality operator, then the code inside will execute. Let's go back to that example with differing data types that are still equal to each other. So you can see this code still executes despite them not having the same data type. Now, we can use a nested if statement with another check to see if the types of the two values are equal. So as you can see, now this code doesn't execute, but if I were to remove the quotes, they will. However, this is kind of tedious and a little bit long. So in order to do this in a shorter way, then we can make use of triple equals instead of double equals. What this will do is it will not only compare the values or memory addresses if they're objects like arrays, they'll also compare the data types of the two values. So if we were to run the code now, you can see the triple equals checks if that they're different data types. So this code will not be executed. And if we replace the first equal sign with an exclamation mark like we did for the double equals, then you can see these might be the same value, but they're not the same data type. So it checks that they're not equal, and then it executes the code down here. The final concept that we'll go over in this video is the else statement. And this is used to run different code if the condition ends up not being true. We can add an else statement here by going to the end of this ending curly brace surrounding this code, and then typing in else, and then another set of curly braces to contain code that runs when this condition is false. So we can say in this one, the condition was false to let us know. And if we run the code, you can see it says the condition was false. However, if we make the condition true by changing the data type of one of the values, you can see the normal message appears. This is useful when you want certain code to run when the condition is true, but you also want other code to run when the condition ends up being false. So if else allows you to do that. And else works with any type of condition, like all the ones that we went through before. So you can check if any condition ends up being true or false, making use of if and else. This concludes this video on the basics of conditional statements in JavaScript. Next video, we'll learn more about conditional statements, including ways to expand them and simplify them, and create more complex Boolean expressions. So, thank you very much for watching. Make sure to like and subscribe if you enjoyed the video, and look out for the next video when it comes out.